In this video, we are going to go over how to graph vertex form of a parabola. And we're actually familiar with vertex forms. We've already talked about transformations, but we're going to review. So vertex form of a parabola is going to look like this. Y equals a times x minus h squared plus k. Now, my vertex is going to come from h comma k. So it's really going to be the opposite of what's in my parentheses with x, and then the same as what's with k. So if I was looking at this first equation, I have 2 and 5. So my vertex is actually going to be negative 2, positive 5, because it'll always be opposite sign, same sign. So if this is negative 1, negative 8, my vertex is actually positive 1, negative 8. Positive 4, negative 3 means to be negative 4, negative 3. And if I have negative 7, positive 9, my vertex is actually positive 7 and positive 9. So now, how does this help us graph? Well, the first thing we need to do is identify the vertex. So again, opposite, same, so negative 2, positive 5. So we're going to plot that point, negative 2, positive 5. Now I'm going to take that vertex and I'm going to put it into the center of my table. I'm putting it in the center because I want to find points on either side of my vertex, so that's why I put it in the middle and not at the top. Now I'm going to put 2 points that are smaller than negative 2 and 2 points that are bigger than negative 2. Now I'm going to plug each of those numbers into my equation to solve for the y value. So first I would plug in negative 4, so y would equal negative 4 plus 2 squared plus 5. And I would just type that all in my calculator just like that. What we're going to end up getting is 9. I would do the same thing, then instead of negative 4, I'm going to do negative 3. When I do that, we're going to get 6. Change this negative 3 to a negative 1, and then we're also going to get 6. And then I'm going to do 0, and we're going to get 9. So now I'm going to plot those points. So negative 4, so 1, 2, 3, 4, positive 9, negative 3, positive 6. I already plotted the vertex. And so this is what my parabola will look like. Now there's a few more things we have to talk about. My axis of symmetry is always the line that makes my graph symmetrical, and it's always going to be the same as the x of the vertex. My axis of symmetry will be right here at x equals negative 2. My y-intercept will always be when my x is equal to 0. So I would plug in 0 into my equation, and I would get 9. Which actually I can see I also plotted on my graph right here. All right, let's do the same thing for number 2. So again, opposite, same. So my vertex is at negative 2, positive 5. But now I have this number in front. So now since my number in front is negative, this actually means my parabola is going to open down. So we'll see that here. So I'll put my vertex in the middle, plot my vertex. Again, my axis of symmetry is always the same as the x of my vertex. So it's going to be x equals negative 2. So it should be symmetrical about this line again. I'm going to pick 2 numbers that are smaller and 2 numbers that are bigger. And again, now I'm going to plug these in. So y would equal negative 2 times negative 4 plus 2 squared plus 5. So we would get negative 3, because we're just going to type this whole thing in the calculator. Now I'm going to replace negative 4 with negative 3, and we would get 3. Then I'm going to replace negative 3 with negative 1. We would also get 3. Then I'm going to replace negative 1 with 0, and we would get negative 3. So let's plot these points. Negative 4, negative 3, negative 3, 3, I already plotted the vertex. And if you notice, they're symmetrical about that axis of symmetry. And let's connect our points. Right now, I can see that my y-intercept is right here at -3, but I'm going to double check by plugging in 0 to make sure that it's right. We would get -3 again. So that means I did my math right. So 0, -3 would be my y-intercept. All right, so now I've given you a graph, and let's write the equation. So first, let's look at where my vertex is. So again, my vertex form is x plus h, or sorry, x minus h squared plus k. So my vertex is right here, so it's at -4, -4. So that means h is -4 and k is -4. But again, it's always going to be opposite, so it's going to be x plus 4 squared and then minus 4 on the outside. But my h will always be the opposite sign. So since h was -4, I have to put plus 4. Now let's review domain. So again, domain is left to right. So if I look at the left side of my graph, this is going to -infinity because it's going to the left. If I look at the right side of my graph, this is going to positive infinity. So my domain is going to be -infinity to infinity. And now this is true for all quadratics. The range will depend on if it has a maximum or a minimum, and I can see it has a minimum here at -4, and then it goes up to infinity for the range. So my range is going to be -4 to infinity. Now it wants me to circle where the graph is increasing. So if I read a graph from left to right, I know that it's decreasing, then increasing. So it's going to increase here. And it wants me to squiggle where the graph is decreasing, so it's going to decrease here. The last thing it wants me to find is f of -3. So again, that's when x is -3. So x is -3 is right here. I'm going to go to my graph and then look at what the y value is, and the y value is also -3.